Yeah, Assalamualaikum. My name is Adam and I am from Group 3, Assignment Group 3, explaining about the quantum models and mechanics. To start with familiarity, as you all know that Bohr model is a 2D model where the electrons are revolving around the nucleus, and the first orbital of the orbit is the duplet where it contains 2 electrons, and the second one is octet where it includes 8 electrons. While it worked perfectly for the hydrogen model, it couldn't account for the fact that of the larger atoms were for these reasonings.
Is light made up of particles or waves? Quantum mechanics says it's both. How can it be both? It can't. But it is. It's paradoxical, and yet it works.
It's for that reason where the Oppenheimer says in the clip, Erwin Schrödinger and Heisenberg in the 20th century have introduced a couple of theories to give birth to the quantum model theory. There are 4 key concepts that you must understand for the quantum model. That is, the first one is N. N is the principal quantum number, and the next one is L. That is the azimuthal number. Next one is ML, magnetic quantum number, and finally MS. That is the magnetic spin. To be explaining about the first key concept, that is N, principal quantum number, we'll start with this analogy of this big building. That is, the first one is N equals to 1, 2, 3, and 4, and 5. So basically we could say this big building, the first floor is N equals 1, the second floor N equals 2, and so on. For L, that is the azimuthal number, that is L starts with equals to 0, 1, 2, and 3, and finally N minus 1. It will go for the third key concept, that is ML. That is, if L equals to 1, that starts with ML equals to negative 1, 0, and 1. So determining the amount of ML is through this formula, that is 2L plus 1. And finally, the last one, that is MS, that is the spin quantum number, is to show that in one orbital, there is 2 types of spin, that is positive 1/2 and negative 1/2. As I've said before, L equals to 0, 1, and 2. These numbers aren't just for fun. While 0 is equals to the shape of a sphere, and 1 is the shape of a dumbbell, and the second one is the shape of a clover leaf. L equals to 0 is S, L equals to 1 is P, L equals to 2 D, and finally L equals to 3 is F. So we'll start with an example of the atom of argon. So the electric configuration is this.
Alright, I want to show an example of an element, that is argon, of its electron orbital. So we can show that the first N equals to 1, that is 1, and you have a shape of 1s. 1s is the shape of this yellow ball, as you can see right here. And then we can go for the second one, that is 2s, and that shows a bigger circle of the gray. You can see it right here, it's just bigger than the yellow one. And the third one is 3s, and it's represented by the blue sphere around this atom, and it's much bigger than n equals to 2 and n equals to 1. And then we'll go of talking about the orbital of E. And as you know, that from the formula of 2L plus 1, it shows that 2L plus 1, 2 times 1 plus 1, and it shows 3 orbitals are in the p orbital, and each of these orbitals have 2 electrons. And we'll show the shape of 2p. This shows the dumbbell shape. You guys can see that, and these dumbbells are placed on each of its axes, and the first one is X, second one is Y, and the third one is Z. And it is the same as for 3p, but it's just overlapping of each other. And we'll start with X, and it's colored by red, and you can see it's overlapped by gray and red. And the second one is 3py, just on and another axis. And the last one is 3pz, and you guys can see this is the full electron orbital simulator, and we can even shorthand the full electron configuration, like right below here there is 1s2, 2s2, 2p6, 3s2, 3p6, and it shows neon 3s2, 3p6, and this is what is called to be a condensed electron configuration. Thank you.
So in conclusion, imagine if the world didn't have the quantum mechanics and models. What would the world be like? So that's all from my group.